Unit 6, part, I believe there's going to be part 6, right? So, let me write down. It's the unit 6. This is part 6. Okay? Lesson 15.4, graphing exponential function. The same as the previous one, right? Constructing, graphing, kind of the same. Okay, graph each exponential function, identify a, b, y-intercept, and the behavior of the graph. And the behavior. And the behavior. What is end behavior? Is when the x value go extremely big or extremely small. One is go positive infinity, another one is negative infinity. Okay, let's write out the formula. F of x equal to a times b raised to the x power. A, in the real world problem, we call it initial value. On the graph, pure math, only number, we call this y-intercept. Y-intercept. So this point is on the y value, or on the y-axis. So this is A, yeah? Y-intercept and behavior. Okay, let's do the first one. So what is A? So f of x equal to a times b raised to the x power. So a is what? A is 4, right? So a equal to 4. B is the base, or the multiplier, or the ratio, common ratio. So it's the base of the exponent term, right? So b is 2. Y-intercept. Y-intercept is when x value is 0, right? X value is 0, so this whole thing will be 1. So the y-intercept is just the A, which is 4. So y-intercept is 4. Or sometimes, if you answer question on the computer-based test, sometimes they maybe give you like a ordered pair for x1 and y coordinate. So you're going to write x equal to 0, y value is 4. So this and this, they both means y-intercept. And the behavior, so we still have to graph it. When x equal to negative 2, right here, x equal to negative 2, so negative 2, 4 times 2 raised to the negative 2 power. So 4 times 2 to the positive 2 power raised 1, all over 1. So 4 times 1 over 4. So this is 1, right? 1. X equal to negative 1. So 4 times 2 raised to the negative 1 power. So it's going to be a positive 1 power, 1 over fraction. So 4 over 2, this is 2. When x is 0, 4. X equal to 1, 2 raised to the power of 1 is 2. 2 times 4 is 8. So this is 8. And then x equal to the last one, x equal to 2. X equal to 2. So 4 times 2 raised to the power of 2. So this part, 2 raised to the second power, or 2 square, is 4, right? 4 times 4, 16. 16. Yeah. Now we figure out the table. 1, 2, 3, 4, 5. 5 ordered pair. So that means it's 5 points on the graph. Yeah. X coordinate, y coordinate. X coordinate, y coordinate. Right? Let's take another look. From the first value, you multiply by 2. You multiply by 2. You multiply by 2. Yeah, you got each point, right? Multiply. Oh, look at here. The multiplier. Yeah, B is the multiplier. multiply each term by 2, you got the next term. Or in the geometric sequence, we call to a common ratio. Okay, enough. Let's plot the point. -2, 1, -2, 1. Oh, the graphing. The graphing paper is not very nice. Look at the x. Is each increment is 1, right? Not even 1, it's half. But the y value, the y-x-axis, each increment, oh, this is 2, 4, 6, 8. Wow. But on the x, so this is 1. And each box, this is half. Yeah, x value is half. So, I need to redesign this. But for now, we just, bear with me, okay. X equal to -2, the y value is, okay, the second point, -1, 2. So -1, 2. Second point, x value is -1, y value is 2. So -1, the x, and here is the y value is 2, right? So the point is right here. So 0, next one, 0, 4. Point right here, x equal to y, 0, y value is 4. 1, 8, 1, 8, 2, 16. Yeah, all the points is done. Now we're going to connect them by a nice curve. Never straight line, okay. And the behavior, that means all the way to this direction. This is when x equal to positive, x goes to positive infinity. So x get bigger and bigger. The y value is going to look like this. The y value is get bigger and bigger, right? So how do we answer this? Okay, let's draw a line. Yeah. And the behavior when x equal to negative, not equal to, x go to negative infinity, which is this end, right? This end is negative infinity. When x goes to negative infinity, the y value get closer to 0. So you're going to put here y getting closer to 0. The end behavior is the graph getting closer to the x-axis. Every point, the y value is getting closer to 0, right? But never equal to 0 or go through the line. Go this part, go below the x-axis, go under it. No. So the graph is always above the x-axis. It almost go flat. Yeah. Okay. On the other side, x go to positive infinity, and the y value also go to positive infinity. So this is end behavior. So first one is done. Let's do a second one. Let me erase some here. Okay, the function equal to 1/3. 1/3 times 3 raised to the x power. Okay, let's start with the -2 first. -2. So the y value is 1/3 times 3 raised to the -2 power, right? So this is 1/3 times 3 square all over 1 all over this. I change the power to positive, and as a big fraction, 1 over it, right? So this is 1/3 times, this part is 1 over 9, right? 3 raised to the second power, or 3 squared is 1 over 9. So this is 1 over 27. Multiplication, fraction multiplication, top multiplied by top, bottom multiplied by bottom, 1 over 27. Oh, this is a very small number. So 1 over 27, let me use my calculator to figure out. 1 divided by 27 is equal to 0.03. 0.03, oh, 0.4. Let me round it. So this is very small. Get very close to 0, the x-axis. getting very close to x-axis. Okay, second one. Second one, x value is -1. -1. That is 1/3 times 3 raised to the -1 power. So 1/3 times 2, 3 raised to the +1 power. So this is 1/3 times 1/3. So this is 1/9. 1/9. 1 divided by 9, that's 0.1. So 0.1. Okay, when x equal to 0, x equal to 0, this part is 1. 1 times 1/3, so this is 1/3. 1/3. 1/3 is 0.3, right? Approximation, rounded, yeah. Okay, next one. When x equal to 1. X equal to 1. 1/3 times 3 raised to the first power. First power is just 3. So 1/3 times 3. Whole number goes to the top, multiplied by the top number. So 1 times 3 is 3. 3 over 3, that's 1. So this is a 1. All right. Let me erase all this. Okay, next one. The last one. Last point. X equal to 2. So 1/3 times 3 raised to the second power. 3 raised to the second power. 3 times 3, that's 9, right? 1/3 times 9. So 9 goes to the top. So 1 times 9 is 9. 9 divided by 3, that's 3. Okay, I'm going to put all the points on the graphing paper. So x equal to 0, so small the value. X equal to -2, the y value very small, right here. X equal to -2. Okay, x equal to -1, a little bigger. X is 0. What? No, my points are gone. 1. X equal to 0, 1/3. Still very small. When x equal to 1, the y value is also 1. Still kind of, my graph is not super accurate. All those points here should be even little lower. Okay, when x equal to 2, the y value is 3. Right here, pretty much. So the graph should look like this. Kind of slow. Okay. According to the function, what is a? The a is the first number, 1/3. A is 1/3. What is b? B is the ratio, the common ratio, the multiplier, which is 3. The base of the exponent. Y-intercept. Y-intercept. Y-intercept is this when x equal to 0. Y-intercept is pretty much a, yeah? So 1/3. Or you can put 0, x equal to 0, y value is 1/3. Either way. And the behavior, the same as the first one, even though the graph a little bit different, but the end behavior are the same, yeah? X go to -infinity, the y value goes to 0. X go to +infinity, y goes to the also +infinity, get bigger and bigger. So this means infinity, right? It's a horizontal 8, number 8. Number 3. Oh, 2 more graph. Yeah, number 3. What is A? A is -3. B is 2. Y-intercept. So also -3. Y-intercept is just the A, right? Okay, let's fill up the table. X equal to -2, so -3 times 2 raised to the -2 power, so -3. I forgot about this. We don't do this at this level. We don't do negative. going to be something like this. We're going to skip this one, okay? We choose the power, A is a positive number, so we don't need to do this one. Let's do number 4. Number 4. A, 3, right? A is 3. A is 3. A is also the y-intercept, so y-intercept is also 3. B is the multiplier, the base of the exponent part. Right? This is B. Okay. Let's do the table. Let's fill up the table. Because the multiplier is 1/2 is less than 1, so the graph is going to look like this. The graph is decreasing. Okay, let's do the first. X equal to -2. So x equal to -2. So 3 times 1/2 raised to the -2 power. 3 times 1/2 raised to the positive 2 power. And then 3 times 1 over 4. So this part, 1 divided by a quarter, that is 4. So 3 times 4, that's 12. This is 12. Or use the method I taught you before. When the power is negative, the base is a fraction. Flip the fraction. So I'm going to show you the other method, okay? Oh, I saw the power is negative. Now I'm going to flip the fraction, the base, right? So 1 over 2, when I flip it, it becomes 2 over 1. 2 over 1 is just 2, right? So 2 raised to the, hey, I can change the power to positive. Now, 2 raised to the second power, 2 squared is 4. 4 times 3, that is 12. I got the same answer, right? 12. Okay. Now let's do the second point. Second point is x equal to -1. Okay, x equal to -1. So 3 times 1 over 2 raised to the power of -1. I'm going to change the power to positive. So I'm going to flip the fraction. So 1 over 2 become 2. 2 over 1 is 2, right? And the positive power. Any number raised to the first power, it just is itself. Still 2. 2 times 3, that's 6. And then power of 0. 0. 1/2 raised to the 0 power is 1. 1 times 3 is 3. So, oops. So this is 3 here. Now, x equal to 1. X equal to 1. 3 times 1/2 raised to the power of 1. Power of 1 just itself, so 3 times 1/2. So 3 over 2. 3 over 2, that's what? That's just 3 divided by 2. 1.5. Look at, this is multiplied by 1/2, which is also divided by 2, right? Divided by 2. Divided by 2. Now the last one, can I just keep divided by 2? Yeah, divide by 2. So 1/2 divided by 2, 0.75. Or you can just use the formula to do it. Use the function to figure out the value. I'm doing a little bit shortcut. Okay, let's do all the point on the graph. -2, x equal to -2, y equal to 12. So -2, the x value, -2 right here. The y value 12 right here. So this is the first point. So the first point right here. Second point, -1. X equal to -1, y equal to 6. -1, 6 right here. This is 6, right? 0, 3. 0, 3. 1, 1.5, 1. Something like this. 2, Okay, connect all of those and make a nice curve. Okay, and the behavior. When x, look, this one is different. When x become bigger and bigger, the graph is reaching x-axis, which is getting the y value gets very close to 0, right? So this is this part, right? X become bigger and bigger, and the y value getting close to 0. Okay, when x become negative infinity is this part, right? X becomes smaller. Okay, look at this part. The y value become bigger, positive infinity, right? So this is y getting closer to positive infinity. So that's it. The space is kind of small here. Just the y goes to positive infinity. Done.